AOPS number 36.30, which is greater, the total number of 5-digit palindromes or the total number of 6-digit palindromes? So a 5-digit palindrome can be written as A, B, C, B, A, and a 6-digit palindrome can be written as A, B, C, C, B, A. And A, in both cases, A can't be equal to 0. So since they all have A, B, and C, the total number of choices is the same because there's 9 choices for A and 10 choices for B and C. So it's the same. So the number of 5-digit palindromes and 6-digit palindromes are the same. AOPS number 36.31. For how many positive integers n less than or equal to 24 is factorial n evenly divisible by 1 plus 2 plus ... plus n? So this thing is the formula for the sum of that is equal to n times n plus 1 divided by 2. And since factorial n is divisible by this, then that integer can be factorial n divided by n times n plus 1 divided by 2. This is equal to 2 factorial n times divided by n times n plus 1, which is equal to 2n times n minus 1 factorial if you take the n and 0 out, divided by n times n plus 1, which is equal to 2n minus 1 factorial over n plus 1 if you cancel the 2 n's out. So then we are looking for values that the n plus 1 at the bottom is divisible by 2n minus 1 factorial. So we first test the numbers. So of course when n is equal to 1 it works. So then we test when n is equal to 2. So when n is equal to 2, then this 2n minus 1 factorial over n plus 1 is equal to 2 times 1 factorial over 3, which is equal to 2 over 3, which is a fraction. And then we test n is equal when n is equal to 3. 2n minus 1 factorial over n plus 1 is equal to 2 times 2 factorial over 4, which is equal to 1. And then when n is equal to 4, 2 times n minus 1 factorial over n plus 1 is equal to 2 times 3 factorial over 5, which is equal to 12 over 5. And if you keep testing some few more numbers, you'll notice a pattern. So the pattern is excluding when n is equal to 2. If n is a prime number, then it will be an integer. And if n is composite, then it's a fraction. And this is because, well, actually, no, it's if this number on the bottom is a prime number, then it will be a fraction, and if it's composite, it will be a whole number. And this is because if n plus 1 is prime, then that means it cannot be split into smaller numbers, and 2 times n minus 1 factorial doesn't contain this number because it's n plus 1 and this is n minus 1 factorial, so it wouldn't contain any numbers that's this number, so it will always be a fraction since the denominator is always bigger, or it can't be divisible by the numerator. So if n minus 1, if n plus 1, the bottom, is composite, then it can be broken down into two smaller numbers, and these two smaller numbers are inside the sum of inside the product of 2n minus 1 factorial, because if you see this 2n minus 1 factorial over n plus 1, this, the bottom, is n plus 1, and the top, the biggest, is n minus 1. And n minus 1 and n plus 1 is just two numbers apart. And any number that is composite can be split into, can be written as a product of two other numbers. Those two numbers won't just be two apart, so it'll definitely be in the sum, in the product of n minus 1 factorial. So if, as long as the n plus 1 is composite, then it will be an integer. So then, instead of finding all the composite numbers, we just find all the prime numbers, and then we subtract that. So the prime numbers from 1 to 24 are 3, 5, 7, 11, 13, 17, 19, and 23. And these are 8 prime numbers. And then since there's 24 numbers in total, since 1 is less or equal to n, which is less or equal to 24, there's 24 numbers, so we subtract it. 24 minus 8 is equal to 16. So the answer is 16. And in case you're wondering why it's from 1 is less or equal to n, it's because it's actually n plus, it's because if it's equal to 0, then n plus 1, well, like, it can't be equal to 0, because like it's a positive integer, so it's from 1 to n to 24. AOPS number 36.33. What is the largest 4-digit palindrome that is the sum of two different 3-digit palindromes? So a 4-digit palindrome that is the sum of two different 3-digit palindromes can be written as 1AA1, because the maximum sum of two different 3-digit numbers is 1998. So the first digit has to be a 1. Since it's a palindrome, it's 1AA1. So if the two different 3-digit palindromes are BCB and EDE, the sum is 1AA1. So that means B plus E is equal to 11, and it has to be equal to 11 because if it's equal, 11, because if it's equal to 1, then either B or E has to be equal to 0, and if it's equal to 0, the first digit will be 0, and that's not possible, so B plus E is equal to 11. So the 10th digit in 11, which is 1, carries over to the next digit, so that means C plus D plus 1 ends with an A. And over here, since we know B plus E is 11, that means A is equal to 1, or yeah, A is equal to 1 because B plus E is 11. So A is equal to 1, or A can be equal to 2 because C plus D, the 10th digit, might carry over. So then we test it. If A is equal to 1, that means C plus D plus 1 is equal to 1. So C plus D is equal to 0. And if A is equal to 2, that means C plus D plus 1 equals 2. Or it can be equal to 12, but first test 2. So C plus D is equal to 1. But since if A is equal to 2, it has to carry over. So then C plus D plus 1 isn't equal to 2, it is equal to 12. So C plus D is equal to 11. So then we test both of these cases work. So then we test it. If A is equal to 1, then the number should be 1, 1, 1, 1. So if we try any two numbers, let's say BCB can, it can be 5, 0, 5 plus 6, 0, 6, because B plus E must be equal to 11. So then it's 1, 1, 2, 1. Whoops, I meant 1, 1, 1, 1. And then for the second case, if A is equal to 2, it should be 1, 2, 2, 1. So then we test numbers again. For example, 7, 4, 7, and 4, 8, 4. And the sum is it's not 7, 8, 4. 4, 8, 4. It should be 4, 7, 4 because it adds up to 11. C plus D. So this is 2, 2, 1. So it's still a palindrome. So that since it asks for the largest 4-digit palindrome, the largest 4-digit palindrome is 1, 2, 2, 1.